your CSM tutor for today. So today we're going to be talking about graph theory, or an introduction to graph theory, with a famous problem called the Konigsberg Bridge problem. So it goes like this. There are islands B and C and land A and D, and there's a river. And there are these lines that represent bridges. And so the question is, can you start at any one of these land masses, A, B, C, or D, take all the bridges exactly once, you can't use them twice, but you can visit, the land masses as many times as you want. It's just that you have to return where you started. So this is kind of hard to think about at first, but it's much easier if you model it into this diagram right here, which is called a graph. The cool thing about this graph is that all of the connections are analogous. So if A could reach B in a bridge, that's an edge, and each of the lands are vertices. So let's define some properties about this graph and all graphs. All graphs have a vertex set, which is the set of all vertices, A, B, C, and D, and that all graphs also have an edge set. And for this graph, the edge set is just A and B and all the other ones. I won't list them all because it takes a while. So a cool thing about the edge set is that the edge set must be a subset of the Cartesian product of the vertex set. And what a Cartesian product, or how a Cartesian product is defined by, is the Cartesian product of two sets A and B are all U and V such that U is a part of A in A and V is a part of B. So any two elements in A and B, they will be ordered in this. They will be contained in this element within the Cartesian product. So with that being said, my first question is, what is the maximum number of edges in a directed graph? Wait for an answer. One way to think about it is to model it in terms of looking at each vertex. And each vertex can connect to v minus 1 other vertices. We assume it can't connect to itself, because that really doesn't have that much meaning. So so each vertex, v vertices, each of them has v minus 1 vertices to connect to. So the total number of edges would be upper bounded in a directed graph by v times v minus 1. And so the next question is, how many edges, what is the size of the edge set upper bounded by in a undirected graph? One way to think about that is to look at each pair of vertices in a directed graph that has the maximum number of edges. They will have an edge pointing to each other, and in an undirected graph, it would just turn into one undirected edge. So, intuitively, it would just be halved for an undirected graph. If you want to think about it another way, you could just think about it as, for the vertex set, if you look at the vertex set, just choose two vertices such that they're not the same. And the total number of ways you can do that, that's the total number of edges you could have. And that is v choose 2, which is equal to this. So that is the total number of edges in the edge set for, the maximum total number of edges in the edge set for undirected and directed graphs. So, am I at 4:30?